Hi, welcome back. We're ready to start Chapter 8, and we're going to be talking about molecular compounds. So, almost all compounds or items that we find in nature are not individual atoms or elements, they're actually combined in nature. And so things like our noble gases, helium, neon, etc., are the only things that are found uncombined in nature. Everything else, oxygen is found as a molecule, even though it's just two oxygen atoms. So, helium is less dense than air, and that's why helium balloons actually float. Not all elements are monoatomic, like I referenced earlier. O2 is a molecule, and it's two oxygen atoms that are combined or bonded together. And so when I go scuba diving, we breathe compressed air. It has the same mixture of gases as were found in the atmosphere. Ionic compounds are generally crystalline solids with high melting points. Hopefully you remembered that on your test. And compounds that are molecules or molecular in nature have very different properties. So water is a liquid at room temperature, carbon dioxide, and if you've ever had to have nitrous, those are gases at room temperature. So there's a wide variety of physical properties with molecular compounds. So the attractions holding together atoms in things like oxygen, water, carbon dioxide, and nitrous cannot be explained using the ideas behind ionic bonding. They are not transferring electrons. So, when we form an ionic bond, one atom is giving up an electron or two, or up to three, and then the other atom is accepting those electrons. When we talk about molecules, we're now going to talk about sharing. They both want the electrons. They're both going to hold on to the electrons. And so there's a bond between them because they are sharing. And that's called a covalent bond rather than an ionic bond. A molecule is a neutral group of atoms joined together by covalent bonds. So oxygen has two atoms of oxygen combined with covalent bonds. So we consider oxygen to be diatomic. That means two atoms of the same molecule or same atom types combined to form one molecule. Other elements are found in nature that are diatomic, and there are actually seven of them. And this is your first little thing I'm going to check for in your notes. I'm not going to say that word. So they are hydrogen. Then you start with element 7, which is nitrogen, and you're going to make a 7 on the periodic table. So nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are your 7. And I need to see those in your notes. Please highlight that. A compound that is composed of two different types of atoms is called a molecular compound. Water would be an example of this type. Molecular formula is the chemical formula of a molecular compound. This is not the same as a formula unit because now we're talking about sharing electrons instead of transferring electrons. Molecular compound shows how many atoms of each element are combined to make that substance. Molecular formula of water is telling you that you have 2 hydrogens and 1 oxygen. Whenever we have one of something, we do not put in a subscript. Butane is something you find in lighters. It's often used in other household torches. It has a molecular formula of C4H10, meaning there are 4 carbons and 10 hydrogens. Molecular formula reflects the actual number of atoms in each molecule. The subscripts are not necessarily the smallest whole number ratio. And let me go back. For butane, I could divide that and make it smaller, But since it's a molecular formula, I cannot do that because I have to indicate that there are exactly 4 carbons and exactly 10 hydrogens. So, molecular formulas also describe the molecules consisting of atoms in one element. For example, oxygen is O2. It has a molecular formula of O2. Molecular formula does not tell you about the molecule structure. So it doesn't tell me how they're connected, how they exist in three-dimensional space. It just tells me how many of each type there is. So here I have NH3. Nitrogen is the blue center atom connected to 3 hydrogens, and we are going to play with some molecular model kits. So carbon dioxide is another molecule, and it has 1 carbon in the center, and that's the black atom in the middle, and then there are 2 oxygens on either side. It doesn't tell me how they are bonded together, though. So, molecular structures are how they are arranged in three-dimensional space. If we look at water, we see that the oxygen atom, which is red, is in the center, and then there are 2 hydrogens, but those 2 hydrogen atoms are not linear. The bond angle is not 180 degrees, but it's bent, and that bond angle is about 105 degrees or so. We will find out why they have that molecular structure. So this is ethanol, C2H6O. An organic chemist would say it differently. It would be CH3CH2OH. And we do that to give you more of an idea of how it's connected. And so the 2 carbon atoms are connected. The oxygen is attached to 1 carbon, and then the hydrogens. Acetylsalicylic acid, which is also what we know as aspirin, has a molecular formula of C9H8O4. What elements make up this compound, acetylsalicylic acid, and how many of each element type are found? Please record your answer in your notes, and I will be checking for this. Please highlight this as well. And so there are 9 carbon atoms, 8 hydrogen atoms, and 4 oxygen atoms. And you can see in this picture how they are actually connected, and they tell you the different colors. I am going to stop here. The second video will be much shorter, but I don't want to go on for too long at one time. So, talk to you later.